So I thought I'd add a little bit to today's lecture just by way of making some corrections and some clarification. First of all, we started with this problem. If you had the equation y is equal to 1 times 1 over 5 to the x, is this exponential growth or is this exponential decay? Well, this is in the form y is equal to a times b to the x. I want to point out that the a is the y-intercept. This is where the graph is going to cross the y-axis. And that's going to be at 1. And at 1/5, it's going to decay. So it would look something like this. It's going to go through the point 0, 1, and it's going to decay, because if you had 1/5 to the 0 power would be 1, 1/5 to the 1 power would be 1/5, 1/5 to the 2 power would be 1/25, and it gets smaller and smaller. If I put a negative sign in front of that, it's going to be the same thing, only it's going to be flipped over the x-axis. So it would look like this, where it's going to be 0, -1, and again, it's going to get smaller and smaller. And this is decay. This is decay. And we were talking about this in class, about how would you write this in terms of its of a logarithm if I were looking for the x value. If I were going to write the inverse of this, I would switch the letters. I would have x is equal to -1 over 5 to the y value. And then I want to solve for y. So I'll take the log of, first of all, I want to get rid of this negative sign. So it's going to be negative x is equal to 1 over 5 to the y. Here I have my base raised to the power is equal to some number. And I can write that in a logarithm form as the power is equal to log in that base of the number. So I'm going to write the power, which is y, which is what we're looking for, which is the inverse of this operation. Y is equal to log of base 1/5 to the negative x. And this threw me for a loop, because you can't have a log of a negative number, but you can have the log of a negative x. And let me show you what this looks like on a graph. First of all, we start off with y is equal to 1/5. This is exponential decay, obviously, and it goes through 1, or y-intercept. If we were to look at the negative of that, here we have, wrong one. If I were to look at the negative of that, it's this one. It's going to flip it over the x-axis. So that goes to the y. Now, if I were to look at the inverse, which is the log of this, it's going to be a reflection across the line y is equal to x. And you can see that original purple line is a purple curve is a reflection across this line y is equal to x. If I were to take the other one, which was the this one, my negative, and I were to do a reflection of it across the y is equal to x, I still have numbers here. Now, I wanted to point out to you, if I have the log of -1/5, it's undefined. But if I do the log of a negative x, well, that's not undefined. One more thing to talk about for today's lesson was this idea of the inverse properties. And you needed this to be able to solve some of the questions today. So if I have the base raised to the power, some power c, is equal to x, and I could also write by the definition of the logarithm, the log of base b of x is equal to c. So I'm going to substitute log of this value in for c. Here, base b of the log of base b of x is equal to x. And that's what I was trying to show before. This is not equal to 1, but this is an inverse operation. So it's equal to just the x. And again, if I were to substitute in b to the c power, we have log of base b of b to the c power is equal to c. Again, this part of it is an inverse operation, so it negates it. Just like if you had x plus 3 and you were to do the inverse operation, you do -3, and what do you end up with is x. So in the same kind of way, this is an inverse operation. And we'll talk about more of that tomorrow, but you needed it for today to be able to do some of the questions on today's exercises. So good.